Nanson's formula is a relationship that describes how, under a linear transformation between three-dimensional vector spaces described by a linear map M, physical areas transform as a function of M. Recall that a linear map can be described by a matrix M, and the determinant of M gives the ratio between the physical volume after deformation and the physical volume before deformation, defined by this triple product. Now let's assume that there are two vectors u and v that circumscribe a physical surface. Under the transformation M, these vectors transfer to mu and mv in a new transcribed area. The original area vector is given by the cross product u cross v. After the transformation, we have a new area vector that's equal to mu cross mv. Nanson's formula provides a relationship between mu cross mv and u cross v. This relationship is given by mu cross mv is equal to the determinant of M multiplied by the matrix, the inverse of M, its transpose, so M power negative t, applied to the vector u cross v. So let's see how we can prove this relationship. So we're going to start with the determinant of M. The determinant of M is given as the ratio of the volumes. Given an arbitrary vector W, the determinant of M is equal to the ratio of the volume after deformation or transformation divided by the volume before transformation. When we rearrange, we get this relationship. And notice that I isolated the arbitrary vector W on both sides. Because I isolated the vector W on both sides, and because we're saying W dot this vector is equal to W dot this vector for any choice of W, because W is arbitrary, I can then assert that these two vectors are equal. So U cross V, this vector, is equal to M transpose multiplied by this vector divided by the determinant of M. When I rearrange, I obtain the Nanson's formula, which states that mu cross mv is equal to the determinant of M multiplied by the matrix, the inverse of M, or the transpose of inverse of M, applied to the vector u cross v.